Welcome to the Advanced Bionics ESPCI 2021 Symposium. Advanced Bionics is a global leader in developing the most advanced cochlear implant systems in the world. We are proud to develop many of the world's firsts and onlys in cochlear implant technology. And once in a decade or so, there comes a breakthrough that opens up totally new horizons. Today, we are thrilled to introduce you to the world's first cochlear implant solution designed for children, SkyCIM, developed together with our sister brand, Phonak, who, as you know, is the world's leading provider of pediatric hearing aid solutions. The ability to hear is transformative. By improving hearing, we give people the opportunity to make powerful connections with their family, with their friends, and the world. And that is what SkyCIM does. It transforms lives. So welcome to the world of powerful connections. Let's take a look. And now, over to you, Stefan.
Thank you, Vicky. A very warm welcome to this AB Symposium also from my end here in Switzerland. My name is Stefan Launer and I'm the Senior VP of Audiology and Health Innovation at Sonova, which is the mother company of Advanced Bionics and Phonak. The topic of this symposium, Pediatric, is something that Sonova has had a very long tradition in. This topic has been a strong field in our various offerings, also specifically in our hearing instrument brand Phonak, which is considered to be the pediatric hearing care leader and has been so for years. I think this to a large extent is due to the very holistic perspective that we take at Sonova and in this case also at Phonak and Advanced Bionics to pediatric hearing care. When we think about products and solutions for the pediatric population, we do not think of the pediatrics, the children, as being just small adults, but we try to understand what their needs are, what the needs of their caretakers, their families are, and develop very specific solutions for them. So the products have a very dedicated technology in them. They have very dedicated features to assure the robustness and the usage of these devices in terms of placement and fixation to the ear to the pediatric population. They also have very dedicated functionalities to really support the listening needs during a day of a child, as well as the needs due to language development in these children. So we have specific technologies designed for children, which we now offer in the hearing instruments as well as in the cochlear implants. But beyond these specific technologies, we also offer other solutions meeting the needs of the children. We have Roger remote microphone systems, which are extremely beneficial in especially school environments. But today we also apply them and offer them for children with specific needs, such as auditory processing disorders or autism spectrum disorders. We offer specific fitting formula for the children to provide optimal audibility and intelligibility, and we provide a lot of support tools, training material, and education material for the hearing healthcare professional as well as for the families. One specific topic that we are also touching upon in this symposium is how we control the hearing instruments to provide optimal listening throughout a listening day of a child. This has been pretty remarkable and interesting research also from our end. Automatic control of hearing instrument and situational adaptation has been in hearing instruments for nearly 2 decades now. But about 10 years ago, we started to deviate from this one-size-fits-all approach where we had a single solution for all populations. And we tried to understand what are the specific needs of children throughout the listening days. So we went out with teams that did recordings of acoustic scenes of children, particularly in schools. We videotaped their behavior, where they looked, how they communicated, and all sorts of things. So we spent weeks with the children, video recording, audio recording, their behavior and the acoustic scenes to understand how our automatic control has to work and perform to provide optimal listening performance in these children. We tested our adult settings and we certainly found a lot of weaknesses, and we learned from that and we built and adapted the pediatric automatic control system. It's the AutoSense system to really provide optimal solutions for the children throughout their listening day. This is just one example to show that at Sonova we take a holistic perspective and we try to look at the children, understand their specific needs, and offer specific solutions across the entire bandwidth of our hearing solutions, cochlear implants and hearing instruments across the board. With this holistic perspective and specific focus on pediatrics in mind, let's take a look at the program and introduce and welcome our speakers. The first speaker is Smita Agrawal, Principal Research Scientist at Advanced Bionics, who will tell us about the pre-market study conducted in India and the rigorous testing in-house to ensure Marvel CI systems are robust for children. The second speaker is Andreas Büchner, Professor at MHH in Hanover. He will provide us with insights on what AutoSense OS is, how it works, and what the benefits of these technologies are to our pediatric population. He will share very new study results suggesting that Marvel sound processors outperform other systems, especially in challenging environments. The third speaker is Susan Aitutis, audiologist at Cambridge University Hospital, who has previously had considerable experience with the Phonak Target hearing aid fitting software. Susan will tell us about her experience using the Target CI fitting software and in particular discuss how this system allows faster, easier and smarter bimodal fittings. The last speaker is Sabrina Longley from Geneva in Switzerland. She will talk to us about her center's experience and results on how Bluetooth streaming and the use of AB's remote app led to significantly better speech understanding through an individually optimized setting, helping teenagers to connect to the moments they love. Enjoy our symposium.
Thank you, Dr. Launer, for the kind introduction and for sharing the journey of the Sky ecosystem. The Sky CIM sound processor brings together the technological power of AutoSense Sky OS 3.0 with ease of fitting with Junior mode, peace of mind with the listening check, along with fun and secure wearing options. It is my pleasure to share with you today the extensive reliability assessment conducted at Advanced Bionics with the Marvel CI hearing system, as well as the findings from a pediatric study recently conducted in India. Let's start with Marvel CI reliability. At Advanced Bionics, providing uninterrupted hearing to CI recipients is a core guiding principle. With Marvel CI, which includes NIDA CIM and Sky CIM, we have paid particular attention to two areas to ensure product robustness and reliability. Firstly, numerous design improvements have been implemented. The TMI, battery connector, cables, and even the firmware are all redesigned to take more use and abuse than the previous generation products. Secondly, new test procedures were conducted to simulate harsh real-world situations and go above and beyond industry standards. For example, this picture illustrates a test where weight is applied to the headpiece cables, which are then rotated thousands of times. The picture on the right shows an apparatus simulating biting on a headpiece cable, something that the cable might encounter in the real world with pediatric CI recipients. Other examples include dropping products from several meters onto various types of flooring and immersing products in different types of waters like bath water, ocean, lake, or pool water, perspiration, 95% humidity, etc. Automated testing was implemented to speed up the effect of all the activities a processor experiences over its lifetime. Activities like button pressing, connecting and disconnecting headpieces and batteries, connecting to Bluetooth for streaming of media and phone calls, etc. were replicated thousands of times. 115 different tests were executed over a runtime of more than 1,300 hours. Real-world use case was tested by adult CI recipients over tens of thousands of hours. Even AB engineers wore implants in a hat so that they could wear Marvel CIs in the real world and monitor them on the go. Analysis of over 25,000 hours of data revealed a downtime of less than 3 minutes. That is an availability of 99.9998%. Any errors that occurred in the downtime auto-healed, that is, the users did not hear any cutouts. The question still remained about the robustness of Marvel CI with children, who, as we know, are the toughest of users. Also, what about the effect of a real-world harsh environment? To answer these questions, we conducted an almost year-long study in India. 15 individuals participated in the study, 14 children and one 12-year-old college-going adult. The study was conducted at Shaba Hearing and Speech Center in Mumbai and at Dr. Manoj's ENT Super Speciality Institute and Research Center in Calicut. Both sites are located along India's coastline, and the CI users experienced torrential monsoons as well as hot and humid summers during the course of the study. Subjects were fit with a Marvel CI wirelessly using NoaLink. Wireless programming experience was stable and especially beneficial during the pandemic. AutoSense OS was provided in the starter program at default settings. Performance was monitored weekly during the first month to ensure optimal hearing outcomes. All subjects successfully used AutoSense OS throughout the study, with 7 requiring some further fine-tuning. In total, the participants used the Marvel CI for more than 56,000 hours. This graph shows the average proportion of time spent in different sound environments. As you can see, the participants spend more than half of their waking hours in noisy environments. While alarming, this is ecologically valid because Indian cities are very noisy and most participants live in multi-family homes. Parents were counseled about this finding and potential benefits of using wireless microphones at home were discussed. Participants were provided a Roger pen as a part of the study. These data, combined with participant feedback, were also used to fine-tune AutoSense OS. Keeping the high ambient noise levels in mind, let's look at hearing performance outcomes with Marvel CI. Within the first few weeks, children reported improved hearing. They heard new environmental sounds, be it raindrops on the roof or a crow cawing outside their home. Parents reported improved incidental listening and hearing over a distance. Children were becoming more confident and engaged more actively in conversations. In the last week of the study, we asked the participants to switch back to their clinical processor to compare outcomes using a 5-point scale. 1 indicating Marvel CI was much worse and 5 Marvel CI was much better than the clinical processor. As you can see, Marvel CI was rated better or much better for overall sound quality, speech perception in quiet and noise, perception of environmental sounds, music, and ease of listening. Speech perception scores with phonetically balanced words were obtained in a non-sound treated room and were found to be significantly higher with Marvel CI. These outcomes are in line with the data obtained with adults in other studies, like the one Dr. Buchner will be sharing soon. Findings also echo the positive anecdotal reports from pediatric audiologists in the US. Regarding usability, Marvel CI was rated to be more comfortable, more robust, easier to wear, and easier to use. Children felt more confident in handling the processor by themselves. They also commented that the curved batteries felt lighter and more comfortable on the ear than straight batteries. Finally, I can't say enough about Bluetooth connectivity. It was the first benefit that everyone noticed. The children were so excited about wireless phone conversations and streaming media. Bluetooth streaming was especially helpful with online learning during the pandemic. Parents commented that it allowed their child to attend online classes more independently and hear their teacher better. For example, one child reported hearing math questions more accurately. Parents also reported feeling less worried about listening in with their child and could do other things in parallel. To summarize, numerous design changes and extensive test methodologies have been implemented so that listeners, young and old, can have an uninterrupted hearing experience with the Marvel CI. And the Marvel CI provides meaningful and effective benefits for children and their families. Finally, our immense gratitude to the study participants and their families. Kudos to the co-investigators, Ms. Jagmag, Ms. Parker, Mr. Sasidharan, and Dr. Manoj. Kudos also to colleagues from AB India and APAC, Mr. Nair, Dr. Simsha, Dr. Banik. Dr. Banik will be presenting additional details from the study later in the conference, and I encourage you to attend his talk. Gratitude also to many more colleagues at AB. In addition to acknowledging them, I hope this long list reflects the immense value and effort placed by Advanced Bionics in conducting this pediatric study to confirm that Marvel CI is ready for the real world. Now, let's hear from one of the study participants and a father about their experience with Marvel CI. Thank you.
हाय, मी अनुष्का मालवणकर आहे. माझं नवीन मशीन आहे, त्याच्यामध्ये ब्लूटूथ असतं. ब्लूटूथमध्ये मला खूप आवडले. ब्लूटूथमध्ये ऑनलाईन क्लासमध्ये टीचर शिकवतात ना, तर मला ब्लूटूथने क्लिअर आवाज येते आणि क्लिअर मला कळते. आणि जुन्या मशीनमध्ये कसं ब्लूटूथ नव्हतं. त्याच्यामध्ये मला हेडफोन घालायला लागतं. हेडफोन आता समज टीचर कमी बोलते, हळू बोलते, तर मला ऐकायलाच येत नाही. व्हॉल्यूम वाढलं की व्हॉल्यूम जास्त वाढत नाही, फक्त तेवढं व्हॉल्यूम असतं तेवढंच आवाज येणार. मग मला काही क्लिअर कळत नाही. मग नवीन मशीनमध्ये मला पूर्ण क्लिअर कळते.
मी अमित मालवणकर, अनुष्काचा फादर आहे. मला हिला जुन्या प्रोसेसरमध्ये आणि नवीन प्रोसेसरमध्ये खूप फरक पडला आहे. जुन्या प्रोसेसरमध्ये जसं काही ब्ल्यूटूथ नव्हतं आणि आता हल्ली सगळे ऑनलाईन क्लासेस आणि चालू आहे, ते म्युझिक व्हिडिओज ते सगळं तिला आता ब्ल्यूटूथमुळे क्लिअर ऐकायला येतं. आजूबाजूचा जो नॉईज रिडक्शन होता ते ब्ल्यूटूथमुळे तो गेला आहे आणि फक्त तिला जे ऐकायचं आहे तेवढंच तिला ऐकायला पाहिजे असतं आणि बाहेरचा नॉईज रिडक्शन एकदम कमी झालं.
Dear ladies and gentlemen, I would like to present study data from our investigations of the NAIDA CI-M90 sound processor in various demanding acoustic scenarios which we assembled in our laboratories. The M of the CI-M90 stands for Marvel because the new system is based on the Marvel platform, which is also being used in top-notch hearing aids made by the sister company Phonak. Now let's have a look at the features of the new Marvel hearing platform. This year, two new devices came into the market. First of all, the NAIDA CI Marvel sound processor and the NAIDA Link Marvel hearing aid. These two go well together because they can communicate with each other. Like with the Forerunner Q platform, they can exchange data and broadband audio. What has been added to those two systems, an important feature, is the Bluetooth connectivity. So there is a very fancy chip built into the systems that can connect to almost any Bluetooth-enabled smartphone. And this allows to use a remote app as a remote control, so patients can do a device check, volume control, program changes, and streaming control, so they can set how to transmit audio and in what situations audio is being transmitted from the smartphone to the two devices. There's also a new automatic feature called AutoSense OS. This is basically a classifier that can differentiate between 7 different scenarios and act accordingly on the signal processing. And this is important for pediatrics. There is a special parameter set, and then this is called Sky OS. There's direct Bluetooth stereo streaming. Stereo is an important feature as well, and the whole thing comes with a new fitting software called Target CI bimodal fitting software, allowing the fine-tuning between the two devices. And there's a NOA link for wireless fitting now compatible with the Target CI fitting software, so you can connect to those patient processors wirelessly without hooking them up to your PC via cable. So now a bit more information on the AutoSense OS. It has 7 different scenarios it can differentiate. There are 3 exclusive scenarios or exclusive programs: speech and loud noise, speech in a car, and music. So when one of those situations is being detected, the processor goes into the according parameter set and stays there until another situation is being classified. And there is no mixing of parameters between those situations here. They are exclusive scenarios. This is different in the non-exclusive blended programs: calm situation, comfort and noise, speech and noise, and comfort and echo. The parameter sets between those 4 scenarios here can be mixed, and this is the very interesting feature which makes the adaptation to any outside world scenario very, very flexible and dynamic. Imagine there's the situation where 2 people are talking to each other in a quiet room, and of course the calm scenario is being selected by the classifier, but then one of those people is opening up a window and there's street noise getting in just a little bit, and so the speech and noise classifier kicks in, but just a little bit, not full throttle, and so those 2 parameter sets are mixed to enhance the voice of the talker and to slightly suppress the incoming noise which comes in through the open window. And then this blending between the 4 scenarios gives a tremendous flexibility to adapt to any thinkable acoustic scenario. So let's dig into the AutoSense OS principle a little bit deeper. So I put in this quite busy slide, but don't worry, I'll walk you through this. In the upper line here, you're seeing 5 different acoustic scenarios: speech and noise, music, speech in a car, speech in a calm situation, speech in loud noise. So the horizontal axis is time in seconds, and the vertical axis is level in dB. And you can see that the first 12 seconds there is absolute silence, and then speech and noise kicks in. Now here you have, in the second line, the probability for the 7 different classifiers. You have to imagine these classifiers as neural networks that work independently for each other, and they are trained on their according specialty, so to speak. So the calm situation classifier first of all sees a calm situation. It is 100% sure in the beginning, because this is quite clear. There are 12 seconds of silence in the beginning of the audio sequence, and then at second 12 the audio kicks in with speech and noise, and so the probability for the calm situation sinks quite rapidly, while the probability for the speech and noise situation increases rapidly. And so after 30 seconds, the speech in noise probability is 100%. And accordingly, you can see that the linked actuators take their action. So for example, this blue line here shows the microphone mode, and this increasing microphone mode indicates a increasing forward-facing microphone setting. So the beamformer is getting more and more forward-facing because the speech and noise situation is being detected to a larger and larger degree. Then of course at some point music kicks in, and different probabilities and actuator strengths are accordingly selected. What is interesting is this little hump here in the beginning of the comfort in noise classifier. So this goes up to something like 10% probability, and then goes down again. This is most likely because if you look at the signal pattern here of the speech and noise in the very beginning, the first few seconds here, there's very little speech modulation. So the classifier for comfort in noise kicks in or increases at first because it's assuming that this is noise only without speech. But then when the speech modulation becomes stronger, the probability sinks again. So I think this is quite interesting, and actually you could look at this slide for hours, but we don't have the time during this session, so we move on. So let's have a quick look at the study group. 20 subjects were included, 10 bilaterals, 10 bimodals, and the age at the time of testing was pretty much average for such a study group, 62.3 years. We compared the new processor with the NAIDA CI Q70 or Q90. These were the processor types the patients had when they went into the study. So the study design, very quickly, the first appointment, we did some baseline testing with the NAIDA Q system in omnidirectional setting and the auto sound setting, and we also tested the new platform, the Marvel Omni versus AutoSense operating system, the new feature. Then patients got the Marvel for take-home experience, and we split the group into 2 arms. One arm received 4 manual programs: calm situation, speech and loud noise, comfort in noise and music, and they could switch between them. The other arm got the AutoSense with the 7 classes and no manual program switching, so the automatic setting did it all on its own. Second appointment, again we compared NAIDA Q, Omni and AutoSound versus Marvel, Omni and AutoSense, and we did a music stereo evaluation, how patients perceive music with those devices. Then the patients got their second take-home phase, and we did a crossover with a group. So the other group got the AutoSense OS, and the AutoSense, the former AutoSense group, the 4 manual programs. And at the third appointment, we again checked NAIDA Q, Omni and Zoom Control Basically, we had a setup where patients had to choose the direction of hearing, either front, right, left, or rear. There were sentences that were presented from those directions, and patients had to choose the right direction to ideally have the best signal to noise ratio. This was done manually with the NAIDA Q and the zoom control function, and on the new platform, the Marvel, the new feature Speech in 360 came into play, which automatically selects the correct direction where the speaker is coming from. So this is a new feature. We tested this against the manual zoom control, which was state-of-the-art on the NAIDA Q platform. Now let's jump right into the results in noise. We're using our 8 loudspeaker setup with noise coming from all directions and speech coming from the front. We use multi-talker babble from the speakers, and we're aiming at the speech reception threshold, where we adjust the SNR such that the patients perceive 50% correct. So the lower the values here, the better the performance. And we're seeing 4 conditions: the NAIDA Q with the omnidirectional setting, NAIDA Q with automatic mode, Marvel omnidirectional, and Marvel automatic. And what we can see is that the automatic features on both platforms do have an effect, a significant effect. So going from NAIDA Q Omni to NAIDA Q Automatic gives us a significant benefit, and the same is true for the Marvel platform. But when we compare the NAIDA Q Automatic with the Marvel automatic mode, then we do have an advantage here of 2.1 dB, and this is statistically significant. So the Marvel platform outperforms the older NAIDA Q platform. These were the acute data. We're also looking at the chronic data 4 weeks after they switch over to the Marvel. So patients had take-home experience here, coming back to the clinic, same setup. We're seeing again the same pattern. When we compare NAIDA Q Automatic with Marvel Automatic mode, we have an advantage, a statistically significant advantage, going from -1.1 dB to -2.9 dB, which is an advantage of 1.8 dB, which is clinically relevant, clearly clinically relevant. Now let's go to the Speech in 360 function, which I already briefly explained on the slides before. Speech in 360 is basically an automatic zoom control, and it can focus to one of the directions, either front, right, rear, or left. And this is for complex listening situations, when you want to listen to somebody to the right or left when you're sitting on a table, for example. And the condition we tested was the NAIDA Q with the omnidirectional microphone versus the NAIDA Q with a manual zoom control, where you could already switch to the 4 main directions with a remote control. And this was tested against the new Speech in 360 on the Marvel platform, which does the switching automatically. Speech perception and noise was measured. We had ALSA sentences presented from those 4 directions in a randomized order, multi-talker babble from all directions all the time, and word understanding was measured in % correct. And here we have the results per direction. So first of all, the speech coming from the front. This is words correct on the vertical axis, and on the horizontal axis we have 3 conditions: NAIDA Q omnidirectional, NAIDA Q with a manual zoom control, and the Marvel platform with Speech in 360. And we can see that Speech in 360 yields the best results, 60% correct, and NAIDA Q Omni has the poorest results, which is what we would expect. We can also see that the zoom control for the frontal direction does help, in fact, on the NAIDA Q platform. If we look at the results when the sentences were presented from the right, we can see again a significant improvement for the Marvel platform over the NAIDA Q platform, and we can also see that when speech was coming from the right, the zoom control feature on the Q series gave no advantage to the patients. The same is true for the rear condition. It even seems that zoom control makes it worse, and Marvel by far outperforms the Q platform, and the same is true for the signal coming from the left. And all in all, if we look at all 4 directions, the average scores here, again, we have a significant improvement for the Marvel platform for both the NAIDA Zoom control condition and the NAIDA Omni condition, which is a great outcome, I would say. To summarize, although the NAIDA Cube performs very well in our multi-speaker test environment, the newest generation NAIDA M sound processor actually outperforms the Q series by 2 dB roughly in this challenging sound environment. Upgrade, by the way, from the NAIDA Q to the NAIDA M platform went very smooth. The parameters from the sound wave could be carried over to the target CI, and yeah, everything was quite uneventful. Our study subjects especially liked the Bluetooth streaming function, and they highlighted this particularly as their favorite feature, and they liked the easy setup, particularly in the stability of the connection. And this was really a very, very strong point the patients made. The Speech in 360 feature showed superior performance over the manual zoom control switching of the NAIDA Q90 series. And this is also an important aspect. The AutoSense OS also offered a special setting for children. This is then called Sky OS to acknowledge the different hearing habits and needs of this patient group. And with this, I'd like to thank you for your attention.
Hi everyone, my name is Susan. I'm a research audiologist at Cambridge University Hospitals in the UK, and today I'll be walking you through how to complete a bimodal fitting using the Target CI software. Now, the Target CI software allows for combined hearing aid and implant programming. In order to do this, you begin by detecting your devices using the center icon here. You get a pop-up window that looks like this, where you select the ear for each device. You walk through all of those tabs along the central area, and then finally, once you're happy with your implant and hearing aid programming, you save those settings into the device using the Save and Close section. Now, what I'll be doing today is walking you through each of these tabs in the center here. So to begin, we start on the Client tab. Now in the top right corner, you can see 3 different color coordinated options. Black is representing tabs where you can have general details or features that adjust both the hearing aid and the implant. In blue are tabs that adjust the implant only, and in orange are the tabs that adjust the hearing aid only. Now, starting on the Client tab, you mainly have your general details. So details about the client. You've got select information about your implant only, implant details, measurement options for impedances, measurement options for NRIs, and then finally more general details relating to your audiogram and ear canal measurements. Now, just a note on the audiograms here, when you choose an audiogram, you are selecting both the hearing test for the right and the left ear. If you change this, you are changing both ears together. This is not an independent feature. Moving on to hearing instruments, all of these tabs are related to general details about both the implant and the hearing aid, and the hearing aid device. You can choose your device under Hearing Instruments, set the acoustic parameters for ear mold or T-mic, for example, under Acoustic Parameters, set the color of either device under Details, and add any Bluetooth accessories that you might have. Finally, the bulk of the fitting information comes under the Fitting tab. The first 2 tabs here are related to hearing aid only, where you can run the feedback manager and run an in situ audiogram. Next, moving on to fine tuning is where you select the fitting formula that you're using for the hearing aid only again. This is typically where we would select a bimodal fitting formula. Here, my example here is using DSL Pediatrics. Now, previously in the target software, you would have had to enter a pairing ID in order to activate binaural streaming. Binaural streaming is now automatically activated. You will see this pop up here when you save and restart the hearing instrument. Additional features that you can select in this tab are for the hearing aid initial fitting, so percentage target gain that you're starting at, as well as bass boost. Moving on, we're getting to mapping. This allows you to create and modify existing maps in the implant alone. You can choose here the strategy, the rate, as well as the filter type, so extended or standard low frequency ranges. You can also adjust your threshold levels and the comfort levels for the implant. Anytime you create a new map, you're going to also be creating a new program. Programs are seen in the fine-tuning tab, which we'll go to next. Now, the fine-tuning tab has quite a few options at the bottom, as you can see. Map options and map input gain, again, is giving you implant-specific settings. All the programs available in both the implant and the hearing aid devices are shown on the side on the left here. Programs are always set bilaterally. In order to make adjustments to individual programs, you will be selecting each program that you want to adjust separately, or you can make adjustments to all programs together by selecting the All Programs tab at the top. Under the gain and MPO, this is a hearing aid specific setting where you adjust the frequency response of the hearing aid only. Moving to program options, this is where you will adjust any noise reduction settings such as wind block, sound relax, and the microphone modes. Noise reduction settings are adjusted independently, and microphone modes can be adjusted either linked or unlinked. Sound recover is also available on the final tab here, where you can adjust the strength of the sound recover. When you are in this tab, you will notice an SR on all of the programs that this is activated in. Finally, moving on to the last two sections, data logging, which automatically shows the data logging features for both the hearing aid and the implant, and then device options. This is where you're going to choose what controls and alerts the patient has access to. Manual controls, choosing if they have volume control and program change, is always a binaural feature. Same with the Bluetooth. Under Bluetooth, you will want to select which is the preferred Bluetooth side. Signals and alerts can be played now to both the implant and the hearing aid, separately or together, and you can choose which alerts are played to which device. Light indicators are joint between the hearing aid and the implant. They're always the same setting. A startup delay is again also joint between the hearing aid and the implant using the same settings. And finally, you are able to activate and deactivate the data logging as required. Now, just to summarize, Target CI means that we no longer require two different programming softwares in order to program the hearing aid in the implant. However, adjustment levels, either for current levels in the implant or gain levels in the hearing aid, are made through separate tabs. Binaural streaming is now an automated feature on save and restart of the device. The features that are always joint between the implant and the hearing aid are the programs, the controls, the lighting features, the startup delay, and the use of data logging. You can adjust independently the microphone settings, the noise reduction features, and any audible alerts that are played to the devices. Thank you very much for listening.
Ladies and gentlemen, welcome to my presentation. I'm Sabrina Langlais and I'm from Western Switzerland University Cochlear Implant Center. In fact, today I'm here to talk about investigation of the NIDA CI Marvel Bluetooth streaming. We are living in a hyper-connected world where everything is connected from device to device. So, Advanced Bionics has at the same time introduced the downloadable AB Remote smartphone application. The AB Remote allows the user to change the environmental balance between the microphone input and the streaming input. Now, let's talk about our investigation. To carry out this study, a total of 12 adults CI users, 8 bimodal and 4 bilateral were recruited. Participants were upgraded from their clinical sound processors and, if applicable, hearing aids to the new Marvel CI system. To take you through the process of this investigation, please note that the speech understanding was assessed via the French matrix test in a setup with 4 loudspeakers, presenting the uncorrelated background noise at a sound level of 65 dBSPL. Then the Bluetooth streaming device is represented by the green symbol with the arrow indicating the streaming to both hearing devices. The target signal was represented in a random order, either from the loudspeaker in the front of the subject or via streaming, while the noise is continuously presented by the 4 gray loudspeakers. The speech test was performed with a fixed ratio of microphone and streaming input, 50-50, then a variable ratio of microphone and streaming input, changed continuously with the AB Remote mobile application using omnidirectional microphone. The results showed for all subjects an improved speech understanding with a streamed signal while individually changing the environmental balance via the AB Remote compared to the fixed ratio between streaming and microphone input. We have also collected subjective feedback of our 12 subjects. So results clearly indicated a group preference for the Marvel CI system compared to clinical used NIDA-Q system, and this in terms of speech understanding, sound quality, listening effort, stability of connection, as well as for phone users. I have now come to the end of my presentation. So let me now summarize the key takeaway of what I talked about. First, an individually set environmental balance significantly enhances speech understanding. Then, feedback to questions confirmed for the use of the phone and for the streaming, a much greater rating for the Marvel compared to NIDA CIQ. And finally, direct streaming was specially appreciated by the subjects. One can accept successful technology adoption amongst teenagers. Thank you very much for your attention.
Thank you for attending our symposium today, and especially also a warm thank you to our guest speakers who shared their very exciting and interesting research results and clinical experiences with us today. I hope you enjoyed the symposium as much as I did. We now invite you to connect with your local AB representatives to learn more about Sky CIM products and the entire ecosystem. We truly believe that the unique technologies that we have developed, like AutoSense OS, helps to optimize the hearing performance of your users in daily life and assures that they can connect to the moments they love. Thank you. Now, back to you, Vicky.
Thank you, Stefan, and all of our guest speakers. Every time we work on bringing new products and services to market, we remain focused on 3 areas we bring the greatest value. First, we are committed to providing our CI wearers the best hearing performance, wherever they are, whatever activities they're doing. Second, our job is to ensure our CI wearers have an uninterrupted hearing experience. We offer technology that is compatible with life. Whether it's someone that needs an MRI scan, wants the most broad choice in mobile phone connectivity, virtually any Bluetooth-enabled device, enjoys water sports, or someone with residual hearing on the other ear that benefits from a hearing aid. We offer technology that provides them with continuous access to sound. And equally important, we strive to be the ideal hearing care partner for our CI wearers, for their families, and for our hearing care professionals. We want to help everyone reach their goals. You know, whether that's hearing better or helping to provide the best care, we are here for you. With Marvel technology and our dedicated pediatric solution, Sky CIM, we welcome you to a world of powerful connections, today and into the future. Thank you for the trust that you put in Advanced Bionics and our products. I sincerely look forward to being able to meet you and greet you someday in person. But until then, please stay safe and healthy.